Another sure bet question we want to look at is electrochemistry. Electrochemistry question will not miss in any chemistry exam. So electrochemistry. Electrochemistry. We need to look at questions in electrochemistry. Look at this question. Use the standard electrode potential for element A to F given below to answer the questions that follow. Elements do not represent the actual symbols of elements. Now you see A plus, this is equation like this. You can look at these equations. Now I want to tell you one thing, that the most positive and the most negative will produce the highest EMF. So when you look at this element F and element A, because the most negative is A, the most positive is F, this one, when you combine them, they will give you the highest EMF. When you see C is 0, 0, and that one is our reference, and that one we know our reference electrode is hydrogen. And then you need to know that the more the negative, the more the reducing agent. The electrode potential with the higher negative value is more reducing power. It is more reactive. Therefore, it will give electrons. The more the positive an element is, the more the oxidizing agent it is. The more the oxidizer it is, the less willing to give electrons, so it will undergo reduction. Which element is likely to be hydrogen? Give reason for your answer. The element that is likely to be hydrogen is C2. Why? The reason, hydrogen, we know that hydrogen is a reference electrode, is a reference electrode whose E standard value is 0.00 voltage. So we know that. So whenever you see the one which is 0.00 volts, then it tells you that one is hydrogen and issue. Which standard value of the strongest reducing agent? The strongest reducing agent, I have told you, it is the one with the most negative. So you can see the most negative, there one is, so that is negative 2.90 V. That is the most reducing agent, right? In the space provided, draw a label diagram to obtain C, when B and D combine. B and D combine. Now we have been told B and D. Now look at B. B is negative 2.38. D is positive 0. So it means when we are going to draw, B is going to give electrons, D is going to receive electrons. So you draw electrode, you put the electrode into and then you remember to draw the salt bridge. You draw the salt bridge, and then you draw the electrode in this side. Then you remember to draw the voltmeter here. Once you have drawn that, the most important thing is to tell us what is inside here, and which one is going to be B, which one is S. And the name this one is the salt bridge. So if I say that this one is B, then the solution inside here should be P positive, the ions of that. And if that means this one is going to be D, and the solution here should be D positive. then the electron should be moving from where to where? From B to D, because B is more reactive. It is going to give it is the one that is going to give electrons, and this diagram is completely perfect for you to get 3 marks. The next question is to calculate the EMF for the cell above. So this one is EMF is equal to E standard of reduction minus E standard oxidation. We have said which one will undergo oxidation. B will undergo oxidation, D will undergo reduction. So you go and write the E for reduction was positive 0.34 minus into minus. That one for this one was negative 2.38. So this one is the same as 0.34 plus 2.38, and that one will give us 0.272 volts, and that is the EMF for this cell. During electrolysis, 2 amperes were passed through. Write the equation for the, so we are reacting copper 2 here. So the most important thing is the copper ion. So copper 2, which is in a solution, we add 2 electrons, it will lose this one to form copper metal. So that is the equation that you need to know how to write. Because it is in a solution, it is in an ions form. So this one is aqueous. It will lose 2 electrons to form, it will regain 2 electrons to form this one. So it will undergo what we call, this is reduction. It will regain 2 electrons to form copper. Determine the mass in the anode, the mass at the anode. But we know before we go, we must get there, the quantity of electricity will be equal to I times time. I represent the current, so the current is 0.2 times time, which is 5. We times 60 to make it to minutes. When calculating this one, time must be in seconds. Time is a must to be seconds. So when you multiply this, you get 3600 coulombs. When you multiply that, you are going to get 36 coulombs. But we know that 1 Fahrenheit is equal to 96,500. But copper, it has 2 Fahrenheit. The charge is 2, so it means it has 2 Fahrenheit. 2 Fahrenheit will be what? 2 Fahrenheit will be 193. This times this, it will be 193,000 coulombs. So 193 coulombs has a mass of 63, because that's 1 mole, which is equal to 63.5 grams. So we will ask, what about 36 coulombs? How many grams will it be? So you multiply, so that is 36 times 63.5 divided by 193, and this one will give us a mass of 1.18 grams. So that is the mass that will be produced during this electrolysis.